So now I want to talk about what happens if we have a binomial times a binomial. How do I know this is a binomial times a binomial? Well, count how many terms are in each of the parentheses. So notice this guy has 1, 2. Remember, that subtraction sign separates. And then 1, 2. Remember, addition sign separates. So we have a binomial times a binomial. Now we talked about distributing method. If you're my distributing fans, you would do the 9x with the 5x. The 9x with the 3. The -7 with the 5x. And then the -7 with the 3. By distributing, and I'll put parentheses so that you can see it really understood as multiplication. With distributing of a binomial times a binomial, you technically did FOIL without even realizing. What does FOIL stand for? Okay. First, outer, inner, last. So first, outer, inner, last. FOIL. What does first represent? First means that you have the first term in this polynomial times the first term in this polynomial. Remember, there has to be a binomial for this to work. So first term times first term. So we did that. First term in this is a 9x. First term in this, 5x. Now what does outer mean? They mean the two terms that are closest to the outside edge. You might be saying, what are outside edges? This is outside in the eyes of FOIL. This is outside in the eyes of FOIL. And then this area is the inside area. So when they're talking about outside or outer, the term that's closest to the outside here, the term that's closest to the outside here. Okay, so that's why 9x and 3 went together. It is the outside times the outside. Okay. They're not technically on the outside, but it's the closest to the outer region. And of course then, what does inside mean? The two terms that are closest to the middle, the inner area. This and this are the two terms that are closest to the inside. Okay? These are closer to the outside than to the inside. So it's inside term times inside. That's why they call it inners. And then how do they do these? It's the last term in this binomial, remember? And the last term in this one. So they considered first, last, first, last. So the two that are in the middle, those are my inners. The two on the outside edges, they're considered outer. So last was last. Now, why do I hate FOIL? Well, FOIL only works if it's a binomial times a binomial. Because once one of these is a trinomial, that kind of throws out what the heck innard is. The other reason why I don't like this method is because these terms play double duty. This was known as first term, but it was also known as an outer term as well. So some people get confused, when should it be first and when should it be outer? So I do not like FOIL. But if you're that person who has always learned FOIL, first, outer, inner, last, feel free to do it this way. Most of you will would just distribute. This was this, this was this. Take the first term and distribute to both of these. Then take the second term and distribute to both of these. And how you distribute? You do multiplication, which I got here without thinking first, outer, inner, last. If we're doing this FOIL or distributing, we would have gotten this column. What we want to do is finish this up by multiplying. How? Do you have any like bases? Or do you have any like items? 9x, 5x. Notice we have two x's. So you're going to put x squared. How do I know I had two x's? There's one here and one here. Now some people always say, well, 9x and 5x, they're just two items. No. Remember with multiplication? This is really 9 times x times 5 times x. So remember back to product rule, I told you you could just put this 5 here and put this x here, so all the letters are together, all the numbers are together. That's why xx always will become x squared. And then 9 times 5, 45. Here, we don't have any like bases, but we have a constant of 3 and a coefficient of 9. So we can multiply those. And then 1x, no x's, there's still technically 1x. Same thing here. Constant, coefficient, you can multiply. No x's plus 1x. Remember, product rule says add. So 0 plus 1, you still have the 1x. If you want to put the little x to the first, that's fine. And then here you have two constants. So that's pretty easy. If you saw this on your own, you know that would just be negative 21. Now, once we got this multiplied out, we have to see if we have any like terms. Notice we do. X squared, x to the first, no x's. See how these two pair up? A lot of times, if you use FOIL, you might have heard that the outer and inner combine. Not always, but the majority of the time, yes. But don't make it always that this and this will combine. Okay? It really depends on what your polynomials are. So I would say about 75% of the time, 80% of the time, these will combine for you. But if this was a squared term, 9x squared, I will tell you that these would not combine. Now that I know that these are like terms, we know that this is a positive. This is a negative. When you have a positive and a negative, we know that we're going to have to subtract. We keep the same variable part, x to the first, x to the first. I know that if I combine these together, it's going to still stay x to the first. But 27 and a negative 35, do the math. You know that this is going to be a difference of 8. And who wins the tug of war? 27 players or 35 players? 35 is going to win. So it's going to be a negative 8. Now that I collect my like terms, remember our final step is to arrange our final answer. Start with our highest degree, 45x squared. Remember, this and this now is this. So negative 8x to the first. See how it's going downhill? We didn't have two different letters, so this is the reason why this works. And then a minus 21. Now that we've learned the FOIL method, I'm going to just redo this problem doing rectangle. And you might be saying, well, why? I kind of understand the distributing. The reason why is because I feel like it's more organized. Especially when you get longer problems. So we're going to use these steps real quick. First, count the number of terms in each polynomial. We said it's a binomial times a binomial, so that means 2 terms by 2 terms. So we're going to draw a big rectangle. Make sure it has 2 rows and 2 columns. and then we're going to place the polynomials on the outside. So let's do that here. So I'm going to draw a rectangle. Okay. This, for some reason, I always say is rows, and this, the second guy, I always say is columns. Okay. So 2 rows, so that means I have to split this in half, because the top is 1 row, and then the bottom is the second row. And then I need 2 columns. Right now I only have 1 column, so I'm going to split this in half. 1 column, 2 columns. If you multiply binomial times a binomial, 2 terms times 2 terms, 2 times 2 is 4. That means you'll have 4 individual squares in your rectangle. Now what you're going to do, since this is a binomial, it can fit here or it can fit here. But because I said this is rows, I'm just automatically going to put it on the side of rows. Since I said this is columns, then I'm automatically going to put it where the columns are. Keeps it organized for me. Then you're going to fill in the individual squares. Remember, if you have the same letters, just add the exponents, because that is the product rule. X, X, keep X. Just add 1 plus 1. 1 on top, 1 to the left, means I have 2 of them. And then coefficient, coefficient, just multiply. Over here, again, no X's, 1x. Remember, we're adding. We still have 1x. Product rule is always adding exponents. And then constant times coefficient, multiply, you get 27. Here, 1x on top, but no x's here. 1 plus 0, you still have 1. 5 times negative 7, coefficient times constant. Remember, positive times negative, negative 35. And then a constant times a constant, you can always multiply, and you get negative 21. Now, why do I like this method more than the distributing? Is because most of the time, not always, but most of the time, your like terms will line up diagonal in this direction. And your highest degree typically is this corner. So 45x squared, there's no other x squares. Then you have your 2 single x's. Remember, this is a positive, this is a negative. So we're going to have to subtract. Remember, 35, 27, when you subtract, we're going to get an 8. Who wins the tug of war? Team negative. X, X stays x to the first. And then this column, or this little cube, put it at the end. Remember, constant terms are written last. So first, second term, third term. 45x squared minus 8x minus 21. Same answer. Except to me, this is a little bit more organized. It's up to you if you like this method or not.